Alright, so this is the video lesson for section 14.1. Alright, so chapter 14 actually has a lot of math, but before you get all upset, it's easy math where you just plug into formulas. And so I would never consider teaching you math on a video lesson. So the first section has no math. So we're going to kind of knock that out in this video session. That way, in class, I can spend more time with you on the math, because I think we all know that some of you struggle with math. Alright. So, chapter 14 is actually one of my favorite chapters. I mean, I know that I said stoichiometry is my favorite chapter, and it is, but gas laws is also my favorite chapters. Let's just face it, they're all my favorite chapters. Alright, so let's go ahead and jump into talking about gas pressure. Alright, so section 14.1, properties of gases. Compressibility is the measure of how much the volume of matter decreases under pressure. So in other words, can I squeeze it into a smaller container? For gases, that's possible. For liquids and solids, not so much. Liquids and solids, the particles are already very close together, so you can't really get them any closer. With gases, they're spread out, so I can kind of press them closer together. And so that's what our second bullet says. Gases are compressible because the particles are far apart. Solids and liquids are not compressible. So when you see gases in tanks like this, or you see like a scuba diver wearing a tank, the reason that those tanks can last so long, because if you've ever seen a scuba diver, some of them nowadays, not a long time ago, but nowadays they have real small tanks, and so normally that should only last you a couple of breaths, but because they compress the gas, it can last you a long period of time. And so again, all they do is squeeze those particles closer together, and then it can fit in a smaller volume. So again, that's a property of gases, not liquids and solids, because those particles are already very close together. So, what causes gas pressure? And what causes it to change? Because gas pressure can change. So, the amount of gas, the volume, and the temperature are factors that can affect gas pressure. But you might again be thinking, well, what is gas pressure to begin with? Well, gas pressure is based on the speed and frequency of collisions between the particles and the walls of the container. So y'all, remember, gas particles are just all over the place. So what happens is they bump into each other and bump into other things. That's what causes gas pressure. Like right now, you have billions and billions of particles of air hitting you in the face right now. You have oxygen hitting you, nitrogen hitting you, all kinds of stuff hitting you right now. You don't notice it, of course, because they're very, very small, and we're used to that pressure. But that's what causes gas pressure, is the collisions of the particles. So when we're talking in the next few slides, if I ask you what happens to gas pressure, then I just need you to think, okay, well, are there more collisions? Because more collisions would mean more pressure. Are there less collisions? Less collisions would mean less pressure. Okay, so if I ever ask you a pressure question, if you can connect it to how often the particles bump into each other, that'll give it away. That'll give you the answer. So let's talk about those three factors affecting gas pressure. Alright, so the first one is the amount of gas. As the amount of gas in a closed container increases, the gas pressure increases because there are more collisions. So it's directly proportional. Now see, proportional is something we're going to talk about a lot. Some of y'all have trouble with it. Directly proportional means if one goes up, the other goes up. They do the same thing. The other one that we're going to talk about is indirectly or inversely proportional. What that means is they do the opposite. So if one goes up, the other goes down. Okay, so what I'm saying is if the amount of gas goes up, the pressure goes up. Okay, so remember, we're thinking about it in terms of how often those particles collide. All right, so think about it in the halls. Let's say you're out in the hall during class change time. How likely are you going to bump into somebody? Well, if you're up at the front, near like the library, that area, or the commons area, you're going to bump into about 400 people. Now, on the other hand, let's say you go out in the hall during class, like you get a pass to go to the bathroom. How likely are you to bump into somebody there? Not real likely, because there probably aren't going to be that many people out in the hall. So collisions are based on the amount of particles. The more particles, the more collisions. Just like the more people in the hall, the more likely you are to bump into them. So if we add more gas, that means more particles, more collisions, more pressure. So think about it as you blow up a balloon. If you only blow it up a little bit, it doesn't have a whole lot of pressure. As you blow it up a lot more, that pressure increases, which is why eventually the balloon's going to burst. All right, so amount of gas and and pressure are directly proportional. As one goes up, the other goes up. So let's look at volume. Okay, so as the volume of a closed container increases, the gas pressure decreases. So unlike what we just talked about, this is opposite. Because there is more room for the particles, so they experience less collisions. And so this would be indirectly or inversely proportional. So what this is saying is as volume increases, pressure decreases. Okay, so indirectly, volume increases, pressure decreases. So let's look at my picture down here. Sorry, it's kind of blurry. Again, you know, I got to use what I can find online, and this was the best one. So we have our gas particles here. So they're pretty close together, so you can tell there's probably going to be a lot of collisions. If we give them more room, we increase the volume, they can spread out more. If they can spread out more, are they more likely to bump into each other? No, they're less likely to bump into each other. So of course, if there's less collisions, that means lower pressure. Lower pressure. All right, it's kind of like if we have everybody running around in one of those small rooms, like, you know, social studies or math, every other teacher here has with me, and then we bring everybody in my room. Like my room, we have more room to spread out, so there's going to be less likely to bump into each other. All right, so volume is indirectly, which means as one goes up, the other goes down. All right, so let's talk temperature. So as the temperature of a closed container increases, the gas pressure increases because the particles speed up, causing more collisions. That's directly proportional again. So remember, directly, they do the same thing. So as temperature increases, pressure increases. And again, as we heat something up, y'all, I need you to ingrain in your mind that temperature is related to kinetic energy. The higher the temperature, the faster the particles. The faster the particles, the more they're going to collide. Okay? If you're carefully walking through the halls real slow, you're probably not going to bump into each other. If the bell rings and you just go running down the hall like a crazy person, you're probably going to bump a couple of people. All right? So the same thing happens with gas particles. As we heat them up, particles move faster, you get more collisions, and that increases pressure. That's why you shouldn't heat a closed container, because pressure will build up and the container can explode. All right, so let's move on to that section assessment. Why is a gas easy to compress? Remember, gases are different from liquids and solids in that their particles are far apart. Okay, so you can compress them because the particles are far apart. Otherwise, there's nothing to push closer. All right, so number one is the particles are far apart. Number two, list 3 factors that can affect gas pressure. Well, we just talked about them. There is volume, there is temperature, and there is amount of gas. Volume, temperature, and amount of gas. Those affect gas pressure. All right, volume, temperature, amount of gas. All right, so number 3, why does a collision with an airbag cause less damage than a collision with a steering wheel? Okay, well, what's the difference in an airbag and a steering wheel? Well, a steering wheel is solid and is really, really hard. An airbag is full of gas, which is compressible. So would I want to hit my skull against something hard or like a big, nice pillow? Probably I'm going to go with the airbag because it compresses. Okay, so the airbag would compress instead of my skull, because when you hit the steering wheel, something's got to give. And most likely in that point, it's going to be you that gives. All right, so the airbag is compressible. Now, of course, this is completely off topic, but one thing you do have to worry about with airbags is because of the chemicals inside, it's kind of like a tiny explosion. That's what causes it to blow up so fast. It can actually burn you. So, you know, that's just, again, not related to this topic, but I always like to point that out too, because sometimes people who have been severely burned by airbags kind of wish that the airbag hadn't deployed. All right, but for our questions purposes, we would want the airbag because it compresses, so it kind of cushions the blow. All right, so let's look at number 4. How does a decrease in temperature affect the pressure of a contained gas? Okay, so if we cool it down, what happens to the speed of the particles? They slow down. If they're slow, are they going to collide more often or less? Well, if they're slow, they're going to collide less often. Okay, so that means less pressure. All right, so how does decrease in temperature affect pressure? Pressure decreases. Okay, if they go slow, not as many collisions, less pressure. So pressure decreases for number 4. All right, 5 and 6. A lot of people have trouble with these. Okay, so let's go over these together. Obviously, we're going over all of them together. So number 5, it says if temperature is constant, what change in volume would cause the pressure of an enclosed gas to be reduced to 1/4 of its original value? Before we answer the question, first we need to discuss, well, how are volume and pressure related? Okay, so look back in your notes packet and you'll see that volume and pressure are indirectly related. So if one goes up, the other does what? Goes down. Okay, indirectly is if one goes up, the other goes down. If one goes down, the other goes up. They do the opposite. Okay, so we're trying to reduce reduce the pressure to 1/4. So we want 1/4 the pressure. We want to reduce the pressure to 1/4. So in other words, we're reducing pressure. So what would have to happen in volume? It would need to increase 4 times. Okay, if I'm going to reduce to 1/4, the other one would need to increase 4 times. Okay, so that would be your answer for this one. Increase volume by 4 times. All right, because again, we want to reduce to 1/4, so I would need to increase to 4 times. Because again, if you give it more room to spread out, less collisions, lower pressure. All right, so let's look at number 6. Assume the gas in a container remains at a constant temperature, so we can't change temperature. How could you increase the gas pressure in the container 100-fold? So we want to make the gas pressure a lot more, 100-fold, 100 times the gas pressure that it was. So how can we do that? Well, you could increase the amount of gas 100-fold. If you add a whole lot more gas, is that going to build up pressure? Yes. Okay, so you would just increase the amount of gas by 100-fold. And 100-fold, y'all, just means like times 100. Like if you started out with, 1 gram, now you have 100 grams, like that. All right, so you could just increase the amount of gas by 100-fold. You could also change volume if you wanted. You could write that. But the easiest thing would be increase amount of gas. But anyway, so good thing we're done because my phone's ringing. So that was section 14.1.